So these are your three reciprocal functions. So COT is short for cotangent. That's the full name for this function. And that is the reciprocal function of tangent. This is secant, without the abbreviation. That's the reciprocal of cosine. And then finally, this is cosecant. That's what the CSC stands for, cosecant. Okay, so all this really means is that if you are looking for the exact value at theta for any of these, say I wanted to find the cotangent value, I would take the tangent value at that particular angle and I would just flip it or invert it. And I could do that with any of these. So we'll do a few examples of evaluating first. So I'm just going to flip back here. So if I want to find the exact value of the cotangent of 225, since cotangent is tangent's reciprocal, this should be the same as 1 over tan 225. So now I would want to know, okay, where is 225? That is right in the middle of quadrant 3, and that reference angle right there is 45. So I'm really finding 1 over the tangent of 45. I don't need to worry about it being negative, because if I do my ASTC, I can see that this is the quadrant where only tangent is positive. So I should know from my chart or from using my calculator that tangent of 45 is 1. And if I flip 1 over 1, I'm just still ending up with 1. So that's the exact value of cotangent of 225. If I want to do cosecant of 240, cosecant is sine's reciprocal, so this should be the same as 1 over sine 240. If I take a look at where where 240 would be, that's also in the third quadrant, but it's a little bit further. That reference angle would be 60. Okay, so this is really 1 over the sine of 60. And if I look back at the ASTC, we said this is where only tangent is positive, so that means this value has to be negative. So again, pulling from my chart, which I should know, the sine 60 value is rad 3 over 2. So now I'm just inverting negative rad 3 over 2. That would become negative 2 over rad 3. So the only problem with that value is I cannot leave a radical in the denominator, as we know, so I have to rationalize this by multiplying by rad 3 on both sides. So my final answer is negative 2 rad 3 over 3. That is the exact value of cosecant of 240. We can do some other things with the reciprocals too. We can simplify expressions, or what I'm going to show you here, you can prove that an equation is true. It's really the same type of process. So the goal is to get these two sides to look exactly the same, because that would show that that is in fact equal. So my goal usually to do that is to try to get everyone in terms of sine and cosine, because that's when we see stuff either start to drop out or we just see it match up easier. So cotangent, I know from one of my quotient identities, is equal to cosine theta over sine theta. So I have that. Now if I think about cosecant and secant, those are the reciprocals of sine and cosine respectively. So I'm allowed to substitute in 1 over sine theta for cosecant and 1 over cosine theta for secant. So ideally, I'd like to be able to cancel something out here, but I don't have matching denominators. That's the only way I'd be able to cancel. So instead, I'm going to employ the keep, change, flip method that works for complex fractions. So when I do that, that turns into 1 over sine theta, which is the keep. This turns into a multiplication problem, that's the change. And flip means I'm flipping 1 over cosine theta to cosine theta over 1. And the rule for multiplying fractions is that I just multiply straight across. So this does in fact end up giving me cosine theta over sine theta. So my proof checks out.